Welcome to lesson 6. In this lesson, we are going to dive into the distribution rollout parameter. What we can do is let's open up lesson 6. Let's go to Forest Pack. Let us select this plane right over here. Modify tab, we're going to add a custom object. So underneath geometry, remember to press the plus sign. Custom object, let's select this little sphere. So it's already started distributing and scattering, but how and why in this way? And that answer is underneath the distribution tab right over there. So the first thing you'll notice is mode. We're going to stick to image in this lesson. Underneath that is a preview of what the bitmap actually looks like. So remember when we're talking about pixels, it's white pixels will scatter an object, black pixels will not scatter. So each pixel on the map is either going to create an item or a gap, depending obviously whether it's white or black. So in this specific example, you can see right over there, this is how it's starting to scatter. Pressing the drop down box, you can see a whole bunch of pre-built bitmaps that has already come in, and again we can dive right through this. Let's choose full for now, and as you can see, basically the entire space is occupied with the scattered object. Looking a little bit further down, we got density. So the density is telling us the density of the actual bitmap. Now if I scroll this up, it is zooming in technically into the actual bitmap, which means we have bigger gaps. The object is not changing in size at all. We are simply zooming in, meaning the pixels are further away from one another. If I zoom out, you'll see that it is obviously becoming more and more dense. So let's change this one to the aisle 1 at the moment. And remember, if nothing is shown, make sure that you're just playing around with the density until you can actually see what you've got. You'll notice that this is locked for now, and we'll dive into pixels a little bit later. Underneath here, we have fit to scene. Now this is a bitmap. If you want the bitmap to be basically centered within your scattered plane, we can say pick start, choose top left hand corner, pick the end, bottom right hand corner. And now what you can see, it's done its best to try basically center the bitmap inside your plane. One thing to note, by doing these two options, we have unticked locked aspect ratio, which means that if we change the units, we're going to start distorting the distribution, and that's not what we want. So let's tick lock aspect ratio. What we can do with the offset is simply offset the X, offset the Y. What I'm going to do is I'm just going to increase this so we can see a few more scatters. Now, the next one is called a threshold, which is really great because this is going to allow us to depict on how many of the scattered objects are related to the pixel. What I mean by that is at 50%, that is telling us that anything from mid-gray onwards will make an item. Anything below mid-gray will not. So, for example, if I put this at 0%, that is saying it does not matter what shade of white towards gray it is, it will scatter an object. Only if it is pure black, then it will not. If I put this at 99%, we are basically saying that everything will not scatter unless it is absolutely pure white. So just remember to play with the threshold if you want more or less of the scattered object. Rotation will allow us to simply just rotate the actual scatter itself, which is again really, really handy. Underneath that is max density. Now, if I put this at, let's say, 1 million, I'm going to scroll and increase the amount of objects, and eventually what's going to happen is I'm going to get an error, and this is just a warning. It's a safety net. It's telling us the density of items has reached the limit. So this is to protect our system from crashing. We can say, okay, if we do want to see more, we can obviously just increase this number. Just be very careful depending on your system resources. Let's decrease the amount of scattered objects we see at the moment. Next we have draw gizmo corners. If I press F3, you'll see these dots are shown over here. That is telling us each bitmap. So you can see the tiling is occurring. So that is one bitmap right over there, and then obviously one over here, over there, over there. So this is a good indication to see if there is going to be any tiling and any repeat patterns. Okay, so that is it for the actual bitmap that we are using that is pre-built in. We can choose a custom bitmap. Again, you can use it in Photoshop. As long as it's black and white, it will work. You can even use gradients. So what I'm going to do is I'm going to go into my material editor, and I'm going to choose this checkerboard material that I created. A simple click and drag, and as I let go, say instance, And now you can immediately see that it is now representing a checkerboard. So let's obviously just decrease the amount of scattered objects. And as you can see, wherever there was white is showing, wherever there's black, there is not showing. Now, generally speaking, if we want to change the size, we can simply go into the tiling. So for example, 5 and 5, and now you can see a really cool pattern is busy showing. So your custom bitmaps are amazing. You can basically create any design that you want and incorporate it into your forest pack. Now, what's important to know is that we now have freedom to choose the pixels. So the pixel ratio is basically telling us how many pixels we want in the actual bitmap. I like to think of this as a percentage. For example, if I choose 10, I like to feel that there's only going to be 10% of the pixels that are visible. 50 will obviously increase the amount that we see. 100 would be obviously 100. Now if I choose 200, that is simply increasing and doubling it up, so just be very careful with that. Next, we have the units. Now it is important to know that when we are choosing a custom image, the density works differently. So I'm going to show you with an example. The first thing that I would like to show you is how to clear the map. So we can right click and say clear. And we are now using the built-in ISLE1 bitmap. What we can do here is the following. If I open up the material editor and I click ISLE1 bitmap, what's going to happen is it's going to show me where that bitmap is stored on my PC, which is great because now I can actually take that bitmap, click and drag it into my slate editor. What I can now do is I can take this bitmap, click and drag and put it into the custom slot. Now, there is a reason that you'd want to use the custom slot versus the actual built-in version of it. Even though it's the same map, they actually react very differently. So let's scroll out quickly, and I've got a section here, built-in map and custom map. So I'm going to click on this forest pack right over here. This one is using one called Groups 2 bitmap, and it's set to 10,000 units. So this is the built-in map. This one over here is the custom map, but it's the same bitmap. So there it is there, Groups 2 bitmap, also 10,000 units. Have a look at the difference. Now, if we click on built-in map and we increase the density, we just discussed it's like zooming in and out of the bitmap, meaning the pixels become closer together or further apart. When it is a custom object, the density over here, when we're using a custom map, is not going to scale the bitmap. It's important to know that. If I scale this up and down, you can see that I'm simply increasing or decreasing the amount of scattered objects we see by controlling the actual pixels without scaling or zooming in. And this is why we get the freedom to choose the pixels over here. Remember, I mentioned it's like 10%, 50%, 200% versus actually only relying on the units. And at the same time, using a custom map allows us to have a map channel open. So what does that mean? Because we cannot scale this image the way that we would scale it in a built-in map version, when it's custom map, we can actually control the scattering using a UVW map modifier. And that's really, really simple. So we need to select our object. Let's add a UVW map modifier to this. So you can see I've added one in there now. I'm going to make sure that it is on channel 2. I'm now going to go into the forest pack itself, and I'm going to change this to map channel 2. And immediately you can see that it has changed. Now what that is saying is that I can actually control the actual size of the scattering using the UVW mapping coordinates. So as you can see, I'm manipulating it using the UVW mapping as opposed to only using the density parameter by zooming in and out. So you got a lot more control when it comes to actually using a custom map. Okay, the next thing that we need to cover is the next tab, which is called the diversity tab. So if you can scroll in and just zoom in right over here, let's go perspective mode, and I've set up 4 objects. Let us go into the forest pack again. We're going to select this object right over here, and then we're going to go into the modified tab, and we're going to add these 4 custom objects. So what I'm going to do is 1, 2, 3, 4. Remember, you can do it with this way or obviously using the tab over there. So let's click the first one, which is the sphere, and the second one, the box, the third one, the teapot, and then the last one, which is the pyramid. Okay, if we scroll down over here, the tab that I want to talk about is diversity. So we've got random, match color ID on map, and then clusters. So random is the default option that is picked, and that's basically telling us that the scattering is going to be completely random. Yes, it is based off your image map, but the actual pattern is going to be completely random, meaning the distribution of all these objects. So if we just increase the amount of scatter we've got, you can see that it is really just a complete random scattering. What we can do is we can say match color ID on map. Now if I select this, nothing really has changed in terms of the scattering options. What has changed is that we can add a map to the actual ID. So there is one thing that you need to do before this, is that you need to be able to take these 4 objects and you have to change the color IDs to the actual colors of the bitmap that you are using. So let's go to Material Editor, and you'll see that I've already prepared 2 maps for us. The first one, as you can see what this is over here, is simply just these colors. We got your red, green, blue, and yellow, and all they are is just in a grid. This one over here, but more advanced, using the same colors, just in some wavy patterns. So the idea is for us to use this map as a distribution map. So taking one step back, we discussed already that the distribution map over here is usually your black and your whites, and it picks up all the pixels, and that's great, we can do that. If you want to get something very, very unique and use different colors for multiple objects, then you're going to want to use the match color ID on map. So if we zoom out here and we kind of just picture what this is going to be like, I'm going to take this map over here. I'm going to add it into the slot over there, and then I want to arrange that all the spheres go where the red is, the box goes where the green is, the teapot the blue, and the pyramid the yellow. Now in order for this to work, what is really, really important is that we need to add the color IDs that we want for each color. So wherever we want the red, green, blue, and yellow to be, we need to tell Forest Pack which item goes where, and that is done using the color ID. So right now I'm going to click on sphere, I'm going to click on the color ID, and I'm going to choose red. Next is the box, and let's choose that as the green. Next, the teapot, let's make that the blue color. And then finally the pyramid, let's obviously just make that the yellow color, and click OK. So that is set up, and that is the most important step, because now when we are going to apply the map into the slot over here, Forest Pack knows which item goes where, because it's going to read the map and then read the color ID. So let's click, drag right there and say OK. And as you can see, exactly what we just discussed. So all of the spheres, they are red, they're in this quadrant over there, and then obviously the box will be there, and teapot, and then the pyramid. And this is really, really awesome. So that is your match color ID on map. The map channel would again work if you added a UVW mapping modifier onto the actual plane or the scattering surface itself. I want to show you again quickly with this. I'm going to click and drag, let go, say instance, and immediately update it. And then of course just play around with the units, and you can see that you can come up some really, really awesome patterns, especially if you're trying to create a specific vegetation or ecosystem. Underneath that is the noise percentage. Now what this is going to do, it's going to give a little bit of randomness into the actual pattern, meaning some of the red will bleed into the blue to the yellow, yellow to the green, and so on and so forth. So let's start with small numbers. Let's go to 10%, and immediately you can see that 10% of all the items have now been scattered randomly. So you can see in the blue we've got a little bit of red, we've got the greens and the yellows, and obviously if you go all the way higher numbers, it's going to just be more and more random. 100% would literally just be complete randomness, which kind of defeats the purpose of using the match color ID. Okay, I'm going to right click and say clear right over there. Let's put this at 0%. Now the next one that we have, if I go back to random just for now, is called clusters. Now clusters are really awesome, because if you look at an ecosystem, vegetation, forests, anything like that, generally speaking, you'll have all of your plants, your trees, your flowers all grouped together in clusters, so they will all be next to each other. And this is what this option is going to allow us to do. So if I activate clusters right over there, and I've already put a value in, you can see that what it's done is it's grouped all of the colors together. So if I scroll to make it a bit smaller, you can start seeing what it's actually done for us. Now you need to imagine this as an actual forest where we've got all a specific trees over there. These can be the flowers, the same trees would be scattered there, and then in between we've got a little bit of the blues. So clusters are a really great way if you're creating an aerial render, or even some vegetation with flowers where you want them to be grouped together in clusters, making it obviously look a lot more unique. And just remember that the object is determined by the color ID. So obviously when you're looking at the red, you know that it is the sphere. So obviously you can change those colors as much as you want. And also important to know that clusters only works with obviously more than one object. So if you're trying to do a cluster with one object, it's obviously not going to work. So just make sure you have multiple objects. Next we have the roughness. Now the roughness controls the randomness in the placement of the scattered items. So the higher the value, the more randomness, and it's going to be less uniform and more natural, where lower values will result in a more ordered and even distribution. So let's start with small numbers. We've got 10%. You can start seeing that slightly changing, 20%, 50%, and you can start seeing the random, unorganized pattern that we're busy getting. Let's take that back to 0. The blurry edges, it softens the transition between the scattered and the non-scattered areas. So items near the edges of the scattered region will actually have a softer and more gradual transition. So if you want to kind of think of this as a fall-off map. So let's actually go into top view and let's put this at 10%. And you can slowly start seeing that it's bleeding into the yellow. If I go 50%, it starts bleeding more and more and more. And then 100%, obviously, you just start getting more of a random transition that's going through it. The noise will randomize, and the noise is this guy right over there, so let's put that at 0. So the noise will randomize the variations in the placement of the scattered item. And this adds a level of unpredictability in the actual distribution. So I press 10%, immediately you can see that all of a sudden there, we got a little bit of red and blue and yellow. So a lot of randomization and a lot of customization can actually happen with these 3 values over here. And the last one is your collisions. Now if you remember, collisions is basically saying that anything near the object will actually get removed or deleted because it's got its own protective bubble and you don't want any collisions to happen in there. And that is it. So for this lesson we have discussed the image mode. The very next lesson we're going to go through path, reference and particle flow.